Hello everyone, my name is Shreya Bhatt and I'm a student at MIT Academy of Engineering. Welcome to the second part of my presentation on DevOps tools and automation strategies. In this session, we will explore various tools like Docker, Jira, Selenium that enables automation in software development and deployment processes, helping organizations deliver software faster and with greater efficiency. Docker. What is Docker? A Docker is a platform that packages applications and their dependencies into containers, ensuring they run consistently across environments. A web application containerized with Docker runs the same on a developer's laptop, staging environment, or production server. Virtualization versus containerization. Unlike traditional virtualization, Docker containers share the host OS kernel, making them lightweight and faster. A Docker container starts in seconds, while a virtual machine may take minutes. Benefits of Docker for DevOps. Docker's lightweight containers enable faster application deployments, reducing time to market. A CI/CD pipeline using Docker can deploy new features multiple times daily. Containers ensure consistent application behavior across development, deployment, testing, and production environments. A works a works on my machine issue is avoided because the same container runs everywhere. Scaling applications with Docker is simple. You can quickly spin up additional containers to meet demands. During a product launch, as an e-commerce platform can replicate app containers to handle higher traffic. Docker architecture and components. Docker engine. Docker engine is the core component responsible for building and running containers. When you run a container, Docker engine manages its life cycle from staging to stopping. Docker Hub is a cloud-based registry where developers can share and store container images. You can pull official images like like Nginx or share your custom app image on Docker Hub. Docker Compose allows you to define and manage multi-container applications using a YAML configuration file. With Docker Compose, you can set up a web server, database, and cache system with a single command. Building Docker images. A Docker file is a text file that specifies the steps for building a container images, including the base image, dependencies, and configuration. Here's a, sa- Here's a sample Docker file for a Node.js app, where the run and npm install can be used to install all the node packages onto your system. The docker build command creates an image from the Docker file, packaging your application and its dependencies. Running Docker containers. The Docker run command starts a container from an image, creating an isolated environment for your application. Docker provides commands to start, stop, restart, and delete configurations, making management easy. Docker Compose for multi-container applications. Docker Compose uses a YAML file to define multiple services and their configurations like images, ports, and dependencies. Compose simplifies orchestration by managing the startup, order, and dependencies of containers. Integrating Docker with CI/CD pipelines. Docker integrates seamlessly with CI tools like Jenkins, GitHub Actions, and GitLab CI to automate the building, testing, and packaging of applications. A CI pipeline can use Docker to build a container image of a web app whenever a developer pushes code to the repository. Docker simplifies the deployment process by creating portable containers that run consistently across environments. Once a Docker image is built and tested in the CI stage, it can be deployed to staging or production environments using CD tools. Jira is a popular tool for agile project management, tracking issues, and improving team collaboration. A development team can use Jira to track features, bugs, and tasks in a sprint backlog. Jira overview and key features. Issue tracking. Jira helps track issues, bugs, tasks, and stories efficiently across the software development lifecycle. Agile boards offers Kanban and Scrum boards for project progress visualization, sprint tracking, and managing work. Customizable workflows. Teams can define and automate workflows tailored to specific processes for improved efficiency. Reporting and analytics provides insights into project performance, identifies bottlenecks, and supports data driven decisions. Integrating Jira with other DevOps tools. Jira integrates with CI/CD tools like Jenkins and GitLab CI to update task statuses automatically based on pipeline results. If a build passes in Jenkins, Jira can automatically mark the related task as ready for review. Jira connects with tools like GitHub and Bitbucket, linking commits and pull requests to specific tasks. A commit message with the Jira issue ID updates the corresponding ticket in Jira. Integrations like monitoring tools like Prometheus or Grafana provide real-time system insights linked to Jira tasks. A production issue detected in Prometheus can create a Jira ticket automatically. Jira workflow for continuous integration and delivery. Jira workflows map the CI/CD lifecycle starting from code commits to production deployment. A workflow could include steps like in progress testing, ready for deployment, and completed. Jira workflows can include manual approval steps for critical deployments, ensuring quality checks. Before deploying a major feature, a manager approves the task in Jira. Automating task transitions in Jira reduces manual effort and keeps teams updated. When a build passes, Jira can automatically move the task to the testing column. Reporting and analytics in Jira. Jira tracks bug trends, helping teams identify recurring issues and areas for improvement. A report showing a high number of bugs in a specific module indicates the need for refactoring. Cycle time measures the time to complete tasks, while lead time tracks the time for the code commit to deployment. A reduced cycle time indicates an efficient development process. Custom dashboards in Jira provide insights into team performance, task progress, and bottlenecks. A sprint dashboard shows completed stories versus pending tasks. Customizing Jira for DevOps teams. Custom fields capture specific information relevant to your DevOps workflows. You can add fields for deployment environments or build numbers in Jira tickets. Define specific transitions like code review or ready for QA to match your team's processes. Tasks automatically transition to in QA after passing CI tests. Custom issue types represent different work items such as bugs, stories, or deployment tasks. Use a use a hotfix issue type for critical production bugs. Agile methodologies in Jira. Jira supports Scrum through sprint planning, backlog management, and burn down charts. Team can prioritize tasks in the backlog and track sprint progress visually. Kanban boards visualize the workflow, enabling teams to manage tasks continuously. A Kanban board shows tasks in columns like to do, in progress, and done. Jira enables lean practices by optimizing workflows and eliminating waste. Tracking cycle time in Jira helps identify and remove bottlenecks. DevOps and Selenium test automation. Selenium is an open source tool for automating web browser interactions. It's widely used for web application testing. You can use Selenium to test user workflows like logging in or adding items to a shopping cart. Selenium integrates with CI/CD pipelines to run automated tests after every build. In Jenkins, Selenium tests ensure new code doesn't break existing functionality. Automated testing with Selenium provides immediate feedback, enabling faster bug fixes. If a UI button stops working after a code change, Selenium catches it early. Role of Selenium in DevOps test automation. Selenium automates browser-based testing, which ensures that web applications work as intended without manual intervention. For instance, Selenium can automatically test whether a user can log in and add items to a cart and complete a checkout process on an e-commerce website. Selenium seamlessly integrates with CI/CD pipelines, enabling tests to run automatically after each code change. In a Jenkins pipeline, Selenium tests can be triggered to validate UI functionality every time a developer pushes a new feature. By automating repetitive test cases, Selenium provides immediate feedback, helping teams identify and fix issues early. In a drop-down menu, if a drop-down menu breaks after a new feature is added, Selenium detects it during the testing phase. Integrating Selenium with DevOps tools for continuous testing. Seleniums can be integrated with Jenkins to run automated tests after every build, ensuring that new code doesn't disrupt existing functionality. If a login feature fails testing in Jenkins, it notifies the team instantly, preventing broken code from reaching production. Ansible automates the setup of test environments and configuration required for Selenium testing. Ansible can provision a clean test environment with the required browser versions and dependencies for Selenium. Selenium can run in Kubernetes as containerized Selenium grid instances, enabling scalable and parallel test execution. A Selenium grid running in Kubernetes can test a web application on multiple browsers like Chrome, Firefox, and Edge simultaneously. Advantages of combining DevOps and Selenium automation. Automated tests with Selenium reduce the time spent on manual testing, accelerating software delivery. A nightly build pipeline can execute hundreds of Selenium test cases, ensuring the application is ready for deployment by morning. By catching the bugs early, Selenium ensures that applications maintain high quality standards. A broken navigation link detected in the staging phase can be fixed before it reaches end users. Selenium also allows testers to focus on complex scenarios while automation handles repetitive tasks. Instead of manually testing login flows every day, testers can focus on advanced user scenarios like multi step workflow. DevOps and Selenium foster better collaboration between development and testing teams, ensuring a seamless workflow. Developers can monitor real time test results from Selenium, enabling quicker debugging. Challenges and best practices for successful DevOps Selenium implementation. Challenges include maintaining test stability across different environments, managing complex test data, and ensuring a comprehensive coverage. Common issue is flaky tests where tests sometimes fail due to environmental factors rather than application issues. Use structured test frameworks, maintain reusable test cases, and continuously monitor automation performance. Implementing a page object model in Selenium helps maintain clean and reusable test scripts. Evolving landscape. DevOps and test automation continue to evolve, integrating new tools and practices to enhance efficiency. The adoption of cloud based testing platforms is making it easier for teams to run tests across multiple environments. Artificial intelligence is transforming test automation by enabling intelligent test case generation and analysis. AI powered tools can predict which test cases to prioritize based on historical defect patterns. Cloud based platforms provide scalable and flexible environments for running automated tests. Testing a module app on different devices and operating system is faster and more cost effective with cloud based tools. Thank you for watching this presentation on DevOps tools and automation strategies. I hope you found this session insightful and useful for understanding how these tools work together to enhance software development. If you enjoyed this video, please like, share, comment and subscribe to my channel for more content like this. Don't forget to ring the bell icon to stay updated on our latest videos. Thank you.